Honda just unleashed a groundbreaking engine that's leaving everyone speechless. This revolutionary V3 design promises unmatched power, efficiency, and innovation, blending speed with precision like never before. Compact yet mighty, it's redefining what engines can do. What makes it so extraordinary? How does it set a new standard in automotive technology? And when can you get your hands on one? Let's dive into the details. What's happening? Honda is no stranger to innovation. For decades, it has consistently set benchmarks in the motorcycle industry, creating machines that are not just vehicles, but experiences. Now, with the announcement of its revolutionary V3 engine, Honda is stepping into uncharted territory, combining groundbreaking engineering with rider-centric performance. At its core, the V3 engine is a bold departure from traditional engine configurations. It merges the compact efficiency of a two-cylinder layout with the power potential of a three-cylinder engine. The result? A design that promises better maneuverability, improved aerodynamics, and performance that rivals larger engines without their typical drawbacks. Why does this matter to you? If you've ever wished for a motorcycle that combines agility with raw power, the V3 engine delivers on that dream. Whether navigating tight urban streets or cruising long highways, this engine is engineered to make every ride smoother, faster, and more responsive. This isn't just an incremental upgrade, it's a paradigm shift. Honda is leveraging its engineering expertise to address challenges faced by both riders and manufacturers, setting the stage for what could become a new industry standard. Let's talk about why this engine layout is such a game changer. The V3 engine anatomy. The V3 engine layout is an ingenious combination of two front cylinders and a single rear cylinder, forming a 75-degree V-shape. This configuration creates a narrow engine profile, reducing the overall width of the motorcycle. A narrower bike has less aerodynamic drag, meaning higher speeds and better fuel efficiency. A win for riders who value performance and cost savings. Traditional engine designs often force a trade-off between compactness and power. Inline engines, while smooth and efficient, are bulkier, affecting handling and aerodynamics. On the other hand, larger V-shaped engines provide better power distribution, but come with increased weight and complexity. The V3 engine bridges this gap, offering the agility of a smaller bike with the performance of a much larger one. Adding to its appeal, the V3 engine is water-cooled. Unlike air-cooled systems that rely on airflow and can struggle in extreme conditions, water cooling ensures consistent engine temperatures even during prolonged rides or high-performance scenarios. This feature also extends the engine's lifespan, making it a reliable companion for years to come. Another highlight is its double overhead camshaft setup, featuring 4 valves per cylinder. This configuration maximizes airflow and combustion efficiency, translating to more power and better throttle response. These components aren't just theoretical upgrades, they directly improve how the motorcycle feels on the road. The electrical compressor revolution. One of the most exciting aspects of Honda's V3 engine is the integration of an electrical compressor. Unlike traditional turbochargers, which rely on exhaust gases to generate boost, this system uses electricity to drive the compressor wheel. This seemingly small distinction has enormous implications for performance and efficiency. In traditional turbochargers, you often encounter turbo lag. The delay before sufficient exhaust pressure builds up to spin the turbine and create boost. This can result in a frustrating lack of power during initial acceleration. Honda's electrical compressor eliminates this issue entirely. By operating independently of exhaust gases, the compressor can deliver maximum boost almost instantly, even at low RPMs. This innovation creates a flat torque curve, meaning consistent power delivery across the entire RPM range. Imagine twisting the throttle and feeling immediate, exhilarating acceleration without any hesitation. That's what this system offers. Smooth, reliable performance whenever you need it. Another advantage of the electrical compressor is its flexibility and placement. Traditional turbochargers require complex exhaust manifolds to funnel gases into the turbine. Honda's system has no such limitations, allowing the compressor to be positioned closer to the intake manifold. This reduces weight, simplifies the engine's design, and enhances responsiveness. However, no technology is without its trade-offs. The electrical compressor does have limitations, particularly in maintaining high boost levels over extended periods. While it excels in delivering short bursts of power, it currently maxes out at around 5 pounds per square inch of boost. This limitation is partly due to the electrical system's capacity, which requires a larger battery and alternator to handle the increased demands. Why does this matter to you? The electrical compressor ensures that your motorcycle responds instantly to throttle inputs, offering a more engaging and confident riding experience. While it may not match the sustained boost of a traditional turbocharger, its ability to deliver power on demand makes it ideal for dynamic riding scenarios, where responsiveness is key. By embracing this technology, Honda is demonstrating its commitment to creating motorcycles that prioritize real-world usability. The electrical compressor is more than just a novelty, it's a practical solution to long-standing performance challenges, making it a perfect fit for modern riders. Engine balance mastery. Balancing an engine with an asymmetrical cylinder layout might seem like an engineering nightmare. 2 cylinders at the front and 1 at the rear could easily lead to uneven vibrations and a less comfortable ride. But Honda's expertise has turned this potential drawback into a masterstroke of design. The key lies in the 75-degree angle of the V3 engine. This specific configuration allows Honda to optimize the firing intervals, creating a natural balance that minimizes vibrations without the need for heavy balancing shafts. This approach not only reduces engine weight, but also enhances the motorcycle's agility and handling. Honda's past experience with V3 engines, such as those used in the NSR 400R and MVX 250F, plays a significant role here. These earlier models demonstrated how careful adjustments to the crankshaft and reciprocating masses could achieve perfect primary balance. The same principles apply to the new V3 engine, but with modern refinements that make it even more efficient. One standout feature is the offset crank pins. The rear piston's crank pin is positioned 105 degrees apart from the front pistons, ensuring that their movements counteract each other. This clever arrangement eliminates rocking vibrations, creating a smooth, consistent power delivery. A balanced engine means less vibration, which translates to a more comfortable ride and reduced fatigue during long journeys. It also minimizes wear and tear on the engine, ensuring that your motorcycle remains reliable over time. Additionally, the unique firing interval gives the engine a distinctive sound and character, adding to its appeal for enthusiasts. Honda's approach to engine balance is a testament to its ability to merge innovation with practicality. By mastering this aspect of the V3 engine, Honda has created a machine that is not only powerful but also refined, offering an unparalleled riding experience. Power potential unleashed. The V3 engine isn't just about compact design or clever engineering, it's about delivering power where it matters most. For a motorcycle enthusiast, power is not merely a statistic, it's an experience. Honda's V3 engine takes the concept of power and refines it to a level that feels both exhilarating and precise. Traditionally, an engine's power output is directly tied to its displacement, but the V3 engine challenges this convention. With a displacement of 700 to 800 cubic centimeters, this engine might seem modest at first glance. However, the integration of an electrical compressor elevates its output, enabling it to deliver performance that rivals larger 1,000 cubic centimeter engines. This translates to an impressive power-to-weight ratio. The V3 engine's ability to produce up to 130 horsepower from its relatively small displacement ensures that it remains lightweight and agile. For riders, this means faster acceleration, smoother overtaking, and a more thrilling overall experience. But Honda hasn't stopped at raw power. The V3 engine is also engineered for efficiency. By utilizing advanced combustion techniques and an optimized intake system, Honda has ensured that this engine delivers more power while consuming less fuel. This combination of power and efficiency sets the V3 engine apart, making it a practical choice for both spirited rides and everyday commutes. Aerodynamics and maneuverability. Motorcycle enthusiasts know that power alone doesn't define a bike's performance. The way a motorcycle interacts with the air around it, the aerodynamics, plays a significant role in its speed, stability, and handling. Honda's V3 engine contributes to the overall aerodynamics of the motorcycle by enabling a narrower and more streamlined design. The V3's compact configuration reduces the motorcycle's frontal profile, cutting through the air with less resistance. This reduction in drag has a direct impact on fuel efficiency and top speed. Whether you're pushing the limits on an open highway or simply cruising through city streets, the aerodynamic advantages of the V3 engine improve the ride in every scenario. Additionally, the narrow engine layout enhances the bike's maneuverability. A slimmer engine allows the rider to lean more naturally into corners, making the motorcycle feel more responsive and connected to the road. This is particularly beneficial for riders navigating tight curves or weaving through urban traffic. The 75-degree V angle also contributes to stability. By positioning the engine's weight closer to the center of the bike, Honda has improved the overall balance, making the motorcycle feel more planted at high speeds. This stability is crucial for maintaining confidence, especially during dynamic riding conditions or long-distance travel. The compressor in action. While the electrical compressor has already been discussed in terms of design, its real-world performance deserves special attention. Traditional turbocharged engines often excel at high RPMs, delivering bursts of power when the engine reaches peak speeds. However, this approach leaves a noticeable gap in performance during lower RPMs, an issue commonly referred to as turbo lag. The electrical compressor in Honda's V3 engine eliminates this problem entirely. By relying on an independent electric motor to spin the compressor wheel, the V3 engine provides consistent boost regardless of RPM. This allows riders to experience seamless power delivery, whether they're accelerating from a standstill or maintaining speed on a straightaway. One of the most noticeable benefits is the flatter torque curve. Unlike traditional engines, which often have a steep rise in torque followed by a drop-off, the V3 engine's torque curve remains steady across the entire RPM range. This results in a motorcycle that feels more predictable and easier to control, especially during quick transitions between acceleration and deceleration. The compressor's placement also plays a critical role. By situating it closer to the intake manifold, Honda has reduced the lag between the compressor generating boost and the engine receiving it. This design ensures that every twist of the throttle translates to immediate action, giving riders a sense of control and responsiveness that is second to none. However, the system is not without its limitations. The 5 psi boost may not seem significant compared to traditional turbochargers capable of generating much higher pressures. But within the context of a lightweight motorcycle engine, this level of boost strikes a balance between enhancing performance and maintaining reliability. Environmental impact and efficiency. In an era where environmental considerations are increasingly important, Honda's V3 engine stands out for its commitment to balancing performance with sustainability. The smaller displacement of the engine inherently reduces its carbon footprint, while the advanced combustion techniques ensure that fuel is used more efficiently. The integration of the electrical compressor further complements this effort. By generating boost independently of the exhaust system, the V3 engine avoids creating the back pressure typically associated with turbochargers. This not only improves efficiency, but also reduces the overall emissions produced during operation. Honda's decision to forego an intercooler, a common feature in high-boost systems, further reduces the complexity and weight of the engine. While this decision may slightly limit the compressor's potential, it aligns with the overall goal of creating an engine that is as efficient as it is powerful. Moreover, the V3 engine's design facilitates smoother power delivery, which can lead to more consistent fuel consumption across different riding conditions. This makes it an attractive option for riders who want performance without compromising on environmental responsibility. Shocking the competition. Honda's V3 engine hasn't just captured the attention of riders, it's sending shockwaves through the motorcycle industry. Competitors like Yamaha, Kawasaki, and even emerging electric motorcycle manufacturers are scrambling to respond. Why? Because the V3 engine addresses a gap that many have struggled with, balancing performance, efficiency, and modern innovation without overcomplicating the machine. The industry is no stranger to rivalry, but Honda's announcement has introduced a new level of intensity. Yamaha has long relied on its CP3 platform for its high-performance 3-cylinder bikes like the MT-09. Kawasaki has stuck to its inline-4 engines to dominate sport bike performance. Meanwhile, electric manufacturers like Zero and Energica are gaining traction with their environmentally friendly designs. Honda's V3, however, occupies a unique middle ground. It delivers power and performance without requiring massive displacement or fully electric technology. What truly shocks the competition is the V3's versatility. This engine isn't tied to one specific category of motorcycles. It's compact enough for use in nimble sport bikes, powerful enough for high-performance naked bikes, and efficient enough to appeal to touring enthusiasts. This flexibility gives Honda a significant edge, allowing it to target multiple segments with a single technological innovation. For competitors, the challenge isn't just matching Honda's engine technology, it's figuring out how to innovate while staying cost-effective. Honda's use of cast components for the V3 instead of expensive billet parts shows that this engine isn't a boutique experiment. It's designed for mass production. This strategy ensures that Honda can scale the V3 engine across a wide range of models, making it more accessible to riders at every level. Market positioning and strategy. Honda has always been a master of market positioning, and the V3 engine is no exception. While many manufacturers focus on niche markets, be it sport bikes, adventure bikes, or electric models, Honda takes a holistic approach. The V3 engine fits perfectly into this strategy, offering a platform that can adapt to diverse riding needs. From an economic standpoint, Honda's decision to develop the V3 as a mass-market engine is a bold move. By targeting riders who want performance without the high maintenance or complexity of larger engines, Honda ensures broad appeal. Unlike premium offerings that cater only to seasoned enthusiasts, the V3 engine also speaks to newer riders who value efficiency and reliability. Honda is likely positioning the V3 engine for use in models that will compete directly with Yamaha's MT Series, Triumph's Street Triple, and Ducati's Monster line. These bikes dominate the naked and sport bike markets, offering a blend of performance and versatility. The V3 engine gives Honda a fresh contender in this space, and its combination of compactness and power could attract riders looking for something truly different. What's even more intriguing is the potential for the V3 engine in touring bikes. Its smaller footprint and efficient design make it an ideal candidate for motorcycles aimed at long-distance riders. With modifications to support larger fuel tanks and additional storage, the V3 platform could be the backbone of a new generation of touring motorcycles that emphasize comfort without sacrificing performance. Consumer benefits and real-world applications. Beyond its technical innovations, the V3 engine has significant implications for everyday riders. For urban commuters, the engine's compact design translates to a motorcycle that's easier to handle in tight spaces. Its improved aerodynamics and lightweight construction make navigating city traffic less of a chore, while the instant power delivery from the electrical compressor ensures quick acceleration when you need it most. For weekend warriors and sport riders, the V3 engine offers performance that feels race-inspired without being overwhelming. The flat, torquey curve ensures predictable handling, allowing riders to push the limits with confidence. Whether tearing through back roads or taking on the twists and turns of a mountain pass, the V3 engine provides a balance of control and excitement. Touring enthusiasts will appreciate the engine's efficiency and reliability. Long rides demand an engine that can perform consistently without guzzling fuel or overheating. The V3's water cooling and optimized combustion system are engineered to handle extended journeys, making it a strong contender for riders who want to explore beyond the beaten path. Perhaps one of the most exciting applications is the potential for aftermarket tuning. The V3 engine's modern design and advanced electronics open up possibilities for customization. From remapping the electrical compressor's boost curve to integrating performance parts, enthusiasts will find plenty of opportunities to make this engine uniquely their own. Future-proofing Honda's motorcycle lineup. The V3 engine isn't just a one-off innovation, it's a signal of Honda's broader strategy for the future of motorcycles. As regulations around emissions and efficiency become stricter worldwide, manufacturers are under increasing pressure to innovate. Honda's V3 engine positions the company as a leader in this evolving landscape, combining performance with reduced environmental impact. This engine's adaptability is a key part of its appeal. While it debuts in a specific set of motorcycles, it's easy to imagine the V3 engine making its way into hybrid designs or even models that incorporate partial electrification. The electrical compressor technology already sets the stage for Honda to experiment further with integrating electric systems, potentially creating motorcycles that bridge the gap between traditional combustion and full electrification. Honda's commitment to refining and scaling this engine also highlights its focus on long-term sustainability. By using materials and production methods that keep costs manageable, Honda ensures that the V3 engine remains viable for years to come. This forward-thinking approach not only benefits the company, but also makes cutting-edge technology accessible to more riders. The V3 engine may also inspire competitors to rethink their strategies. As Yamaha, Kawasaki, and others observe the success of this platform, they'll be forced to innovate in ways that push the industry forward. This kind of competition ultimately benefits riders, as manufacturers strive to outdo one another with more advanced, reliable, and exciting motorcycles. Overcoming engineering hurdles. As groundbreaking as Honda's V3 engine is, no innovation comes without its challenges. Moving from prototype to mass production is a monumental task that requires overcoming both technical and logistical obstacles. While Honda's engineering expertise gives them a strong foundation, scaling this advanced engine for widespread use presents unique hurdles. One of the primary challenges lies in the electrical compressor. While it offers significant benefits, its reliance on a robust electrical system requires motorcycles to incorporate incorporate larger batteries and alternators. This could slightly increase the bike's overall weight and complexity. While the current weight penalty is minimal, it remains a factor Honda must carefully manage as the V3 engine is integrated into various models. Durability is another consideration. The electrical compressor must withstand prolonged use across a range of conditions, from city commuting to high-speed touring. Ensuring that the system performs consistently over time will be key to maintaining Honda's reputation for reliability. Early adoption of this technology may require additional testing and refinement, but Honda's history suggests they are well prepared for this challenge. Mass production also introduces the need for streamlined manufacturing processes. The V3 engine's advanced design, while innovative, requires precise assembly to maintain its performance and balance. Honda's use of cast components indicates they've already considered scalability, but transitioning from limited production to full-scale manufacturing will test even their well-established processes. Reliability and maintenance. Reliability has always been a cornerstone of Honda's engineering philosophy, and the V3 engine is no exception. However, with new technology comes the potential for unforeseen issues. For riders, the question isn't just how well the engine performs, but how easy it will be to maintain and repair. The electrical compressor introduces an additional layer of complexity compared to traditional engines. While it eliminates the need for intricate exhaust manifolds, its dependence on a robust electrical system means that diagnosing and fixing issues could require specialized tools and knowledge. Honda will need to ensure that dealerships and service centers are equipped to handle these requirements. Another factor is the long-term availability of replacement parts. Advanced components like the electrical compressor and the V3's precision-engineered crankshaft must be manufactured consistently to meet demand. Honda's ability to manage this supply chain will be crucial in maintaining rider confidence over the life of the engine. On the upside, the V3 engine's simplified exhaust system and compact design should make routine maintenance tasks, like oil changes and coolant checks, more straightforward. Moreover, Honda's extensive service network and commitment to training technicians on the new V3 engine will play a vital role in ensuring smooth maintenance and repairs. By balancing innovative technology with practical maintenance considerations, Honda can ensure that the V3 engine appeals to a broad range of riders, from tech enthusiasts to everyday commuters. Scaling to mass production. Honda's vision for the V3 engine is clear. This is not a limited edition experiment, but a foundational platform for a new generation of motorcycles. However, achieving this vision requires overcoming the hurdles associated with scaling production. The use of cast components rather than expensive custom machining is a step in the right direction. It signals that Honda is focused on making the V3 engine accessible to a wide audience, not just a niche market. This approach also reduces costs, making the engine a viable option for mid-range motorcycles without sacrificing performance. Honda's global manufacturing network is another advantage. With production facilities across multiple regions, Honda can localize manufacturing to meet regional demands while keeping costs under control. However, ensuring consistent quality across all facilities will be critical, especially for an engine as advanced as the V3. Finally, Honda must navigate the market's response. While the V3 engine has generated significant buzz, its success ultimately depends on how well it resonates with riders. Pricing, availability, and the performance of early models will shape perceptions, influencing whether the V3 becomes a long-term staple in Honda's lineup or a stepping stone to even greater innovations. The road ahead. The introduction of the V3 engine is more than just an engineering milestone. It's a statement of intent. Honda is signaling that it's not content to follow trends, but to lead them, pushing the boundaries of what motorcycles can achieve. The blend of compact design, innovative technology, and practical usability positions the V3 engine as a pivotal development in modern motorcycle engineering. What lies ahead for Honda and the V3 engine? The potential is immense. This platform could inspire further advancements in hybrid systems, adaptive engine management, and even lightweight touring motorcycles. By combining the V3 engine's flexibility with Honda's commitment to sustainability, the company is well positioned to navigate an industry that's rapidly evolving toward greener and more efficient technologies. For riders, the V3 engine represents an exciting step forward. Whether you're drawn to its innovative design, its promise of enhanced performance, or its real-world practicality, the V3 engine offers something for everyone. It's a bold reminder that Honda's legacy isn't just about the machines they've built, but the experiences they've created and continue to create for riders around the world. So, what do you think about Honda's revolutionary V3 engine? Is this the innovation the motorcycle industry needs, or do you see potential challenges ahead? Share your thoughts in the comments below. We'd love to hear your perspective. And while you're here, don't forget to like this video and subscribe to our channel so you never miss our latest updates. Thanks for watching.